So today we're going to look at single variable addition subtraction when we have other indices. So what I mean is that we can still have our variable as x, right? So if you see, we have x here, and then we have x squared, and then x cubed, and we can keep going, right, with more and more powers or indices or exponents, as if you want to call them that. However, we cannot simplify them or collect them together, even though they have the same x. It's because these little powers, because x, there's an x to the 1 up there actually, they all differ, right? And the reason why is we'll get to later, but for the understanding for now, just think of it this way. Think of x just as your length, okay? So the way that we get x squared is we do an x times by an x, right? And it results in this area, which is x squared, because we know that an area of a square is just one of its, or it's our length times our width, or our rectangle, right? It doesn't matter. We're doing x times x, which is a perfect square, so we get x squared. So we have our length equals x. And then similarly, if we look here for a right one, this is a volume. You can't really represent it too well to show this, but same thing, x times by x squared, and we'll see that as, well, that's basically the side, one of its sides cubed. So we have x to the power 3, because each side will be x based on what we did here. So, like I said, we'll get into this later. It'll be called the law of indices, multiplication law. However, for now, you just have to understand that we cannot combine things of different powers because, hey, they're all going to give different units. Length could give you centimeters, area could give you centimeters squared, and volume could give you centimeters cubed. So, it's like saying you can't combine a ruler with a water bottle with the flat top of your desk, right? It's just three things that you cannot combine, right? So just keeping that in mind, we're going to look at some examples. So our first example, we have x plus x squared plus 2x. So we looked at before about underlining or circling things that were similar, right? So here I have my x and 2x are similar here, and then I have x squared here. So once again, I'm just going to rewrite them and bring that 2x out front there, so it's easier to see. Once again, you do not have to do this step if you can see it, but here x and plus 2x is 3x, and then we just have plus x squared. So that's as simple as we can make that. Similarly with the next one, simplify y plus y cubed plus y squared plus y squared minus y cubed. So I deliberately made it really awkward and confusing so we can move stuff around. So you can see the benefits of why we move stuff around sometimes. So anything with a y, I'm going to write like that, and I'll just write y plus y. Then I'm moving along. I want to find the next. It's kind of convention that we just go y, then y squared, then y cubed, so just keep incrementing their powers, right? So I'm going to look at this y squared and this y squared. They're both positive, so plus y squared plus y squared. And lastly, I'll do in green, I have this plus y cubed, and this minus y cubed. So, pretty quick, we can see y plus y is 2y. Y squared plus y squared is plus 2y squared. And lastly, y cubed minus y cubed, well, that's just 0. So we have plus 0. So we can just rewrite it without that plus 0. Could have done that before. However, I just wanted to show you all the steps. So obviously you do not have to show all these steps. Some of you may be able to just do this in one step, just jumping from here to here or just here to here, and that's completely fine, and continue on. Because typically these are 1 mark questions, just can you simplify or not. So last one, a little bit more challenging, complicated, but we'll just take it as normal. So I'm just going to look from any x's. So I have x plus x, or x plus 3x, sorry. Next I have 3x squared. So notice I'm just rewriting, and then here I have a minus x squared, negative x squared. So a minus minus, we know that this is just going to be a positive, right? So we have plus and then x squared. So we combine them, 3x and 3x is 4x. So I'll just do this in black. So 4x and 3x squared and x squared, that's just 4x squared. So 4x to the power of 2